We should consider that in the inner world, Brahman is consciousness, and we should consider that in the outer world, Brahman is space. Part 1. The Logic of an Expanding Universe. Infinite and finite models of the universe. What does it mean to say that the entire universe is expanding? The whole universe can only be getting bigger, in any real sense, relative to some other reference frame. Expansion is not a meaningful concept without a reference frame relative to which the expansion occurs. It is common for non-scientists to immediately recognize this problem when they ask, what is the universe expanding into? At the most basic level, there are two scientific models of the universe today, infinite and finite. Both models struggle in their own way to explain the universe's expansion. In infinite models of the universe, the expansion we observe only applies to our portion of infinity. Within this infinite space, there could be millions of other universes, each of them expanding relative to an infinite reference frame. The question, what is the universe expanding into, is therefore not answered so much as it is excused by invoking the speculative concept of infinite space. The conceptual problem of the whole universe getting bigger is absolved of its problematical nature. Even though the whole universe is expanding, it is not getting bigger in any real sense because space is infinite. Finite models of the universe, on the other hand, immediately face the problem of an inconceivable edge of the universe itself. Scientists typically address this problem by hypothesizing a fourth spatial dimension. The analogy of a sphere is often used. A sphere is a three-dimensional shape whose two-dimensional surface has no edge. Finite models propose that the entire known universe is like the surface of a sphere. The three-dimensional universe would have no edge if it formed another type of sphere in a fourth spatial dimension. As the three-dimensional universe expands, its four-dimensional shape would grow in volume in the fourth dimension. But consider what it means to say that the entire universe has a shape. The whole universe can only have a shape, in any real sense, relative to some other reference frame. Shape is not a meaningful concept without a reference frame relative to which the shape takes its form. So, if the universe is shaped like a sphere relative to the fourth spatial dimension, is the fourth dimension infinite, or does the fourth dimension itself have an edge? Ultimately, finite models of the universe can only extend the problem of an edge to another dimension. The question, what is the universe expanding into, is therefore only answered with a temporary stopgap. Finite models of the universe are perpetually undermined by an infinite regress in perspective. In summary, the fact that the universe is expanding destabilizes both infinite and finite models of the universe. It is difficult to overstate the crisis in our theoretical picture of reality. Infinite models can only excuse the universe's expansion as a local phenomenon, while finite models can only push away the inconceivable edge of the universe to another dimension. If a scientist chooses to interpret the expansion of the universe as a simple fact, in other words, if the whole universe is actually getting bigger, it becomes impossible to conceptualize how the universe could be either infinite or finite. This crisis is occurring at the most basic level of our analysis. The only way out, therefore, is to reconsider the basic logic of a universe that expands. The fact that the universe is expanding is actually only half of the fact in question. The other half of the fact, the reference frame relative to which the universe expands, must also be accounted for in order to arrive at any picture of reality that is logically coherent. In short, the fact that the universe is expanding compels us toward a concept of that which is not the universe. The fact that the universe is expanding implies the existence of an entirely different aspect of reality. To better understand this crisis in the structure of our theories, it is helpful to review a recent historical analog. A brief history of absolute space. Writing near the end of his life, Albert Einstein compared and contrasted two distinct concepts of space: space as the positional quality of material objects, and space as the container of all material objects. In case A, Einstein reflected, quote, space without a material object is inconceivable, unquote. While in case B, quote, a material object can only be conceived as existing in space. Space then appears as a reality which in a certain sense is superior to the material world, unquote. According to Einstein, one of Isaac Newton's greatest achievements was to fully and clearly realize that, quote, space concept A was not sufficient to serve as the foundation for the inertia principle and the law of motion, unquote. Speaking of this achievement, Einstein continued, quote, what is essential is that besides observable objects, another thing, which is not perceptible, must be looked upon as real, to enable acceleration or rotation to be looked upon as something real, unquote. Consequently, Newton embraced space concept B, despite reasons to feel uneasy about that decision, which were apparent to both him and his detractors. Quote, space is not only introduced as an independent thing apart from material objects, but also is assigned an absolute role in the whole causal structure of the theory. This role is absolute in the sense that space, as an inertial system, acts on all material objects, while these do not, in turn, exert any reaction on space, unquote. This decision was, according to Einstein, not logically inadmissible, although it is unsatisfactory. For its time, Newton's decision was, quote, the only possible one, and particularly the only fruitful one, unquote. But in the ensuing centuries, problems associated with the concept of absolute space became increasingly acute, which ultimately led to a new concept of space put forward in Einstein's general theory of relativity in 1915. This long history in the development of theory can be summarized as a three-step process, wherein scientists confronted an inconceivable pre-theorized space as the positional quality of material objects, which was then transmuted into an absolute space that acts on material objects but is not acted upon by them, which was finally transmuted into a reciprocal space that both acts on material objects and is acted upon by them. A Problem Resurrected. When Edwin Hubble produced evidence that the universe is expanding in 1929, the recently deceased idea of absolute space was quietly resurrected. Only now that idea was pushed up into a higher level of analysis. The question was no longer about the reference frame for material objects inside the universe, but about the reference frame for the universe itself. Scientists found themselves in a position similar to Newton's. They confronted an inconceivable nothingness outside of the expanding universe, but not to conceive of it was to relinquish any logical understanding of a universe that expands. In the intervening years since 1929, the scientific community has abdicated its responsibility to resolve this catch-22. The following discussion between two astronomy reporters illuminates the prevailing approach to the problem. We get this question all the time. What is the universe expanding into? What's outside the universe? The standard answer is, it's a nonsense question. That's what I thought you were going to say. So, what does that mean? Why is it a nonsense question? To say that there's something outside of the universe, that means that outside of the universe has to exist. We say that all there is of space, all there is of time, everything that is everything is inside of our universe. But if the universe is expanding, then there must be something that it's expanding into. Why can't you just say that everything that is everything is expanding? To summarize, when scientists confronted an inconceivable nothingness outside of the expanding universe, they denied that it was logically necessary to incorporate this nothingness into the structure of our theories, as Newton had done before. As a result, the expanding universe creates a logical conundrum that scientists can only explain by resorting to aphorisms. But while most scientists explicitly reject the idea of a reference frame for the universe, they implicitly embrace this idea in the guises of infinite space and a fourth spatial dimension. In other words, our standard models of the universe quietly rely upon an absolute reference frame for their logical coherence. This reference frame is absolute in the sense that it enables us to conceptualize the entire universe expanding, while the expansion of the universe does not, in turn, exert any reaction on the reference frame itself. This is true for both infinite and finite models of the universe. In the first case, an infinite reference frame enables the expanding universe to be looked upon as something real, but this expansion exerts no effect in turn on the concept of infinity. In the second case, a fourth spatial dimension enables the expanding universe to be looked upon as something real, but this expansion exerts no effect in turn on the fourth spatial dimension. In short, since 1929, scientists have tacitly assigned the concepts of infinite space and a fourth spatial dimension an absolute role in the whole causal structure of our theories, which is not logically inadmissible, although it is unsatisfactory. Review. In any other thought experiment that did not involve the universe as a whole, the assertion that, quote, the universe isn't expanding into anything, it's just expanding, unquote, would be instantly recognized as logically incoherent. For example, the balloon isn't expanding into anything, it's just expanding. Yet it prevailed as scientific wisdom throughout the 20th century, because despite being logically incoherent, this assertion was still mathematically coherent. The expansion of the universe could still be described mathematically without accounting for the reference frame relative to which the expansion occurs. But in the last 20 years, in addition to being logically incoherent, our models of the expanding universe have failed spectacularly on a mathematical level. In order to explain the observed expansion history of the universe, theoretical physicists must admit to neglecting roughly 2/3 of reality, in literal terms, the biggest crisis in the history of science. Furthermore, the most popular guess at how to resolve this crisis, by considering dark energy to be a form of vacuum energy, produces what has been dubbed the worst prediction in the history of physics. The expansion behavior of the universe implies that the density of dark energy in space is 120 orders of magnitude lower than what is predicted by the otherwise successful quantum field theory. And yet this failure to describe the expanding universe mathematically does not seem to have provoked anyone in the scientific community to reconsider the basic logical conundrum at the foundation of our theories, namely, that the expansion of the whole universe is somehow a meaningful concept without accounting for the reference frame relative to which the whole universe expands. Currently, regular people are able to intuit the seriousness of this conundrum, while the scientific community is not. But in defense of the scientific community, the idea of a reference frame for the universe itself is not explicitly conceivable from the contemporary scientific perspective. Science today defines reality exclusively in its objective external aspect, which is another way of saying that reality is defined as an area. The universe is a spatially extended area that contains everything that is everything. It follows that any reference frame outside of this area is ultimately just more area. Properly speaking, there is no outside or reference frame to even imagine. And yet, for almost a century, scientists have employed the speculative concepts of infinite space and a fourth spatial dimension to play the role of de facto reference frames for the universe in the structure of our theories. Infinite space and a fourth spatial dimension play the role of that which is outside the universe, while at the same time they are necessarily interpreted as theoretical features of the universe. By allowing this contradiction to exist at the foundation of our theories, scientists could make the illogical claim that the universe expands relative to itself, or the universe doesn't expand relative to anything, it just expands. In other words, the universe is both infinite and expanding, or the universe is both finite and edgeless. The essential point is that scientists were compelled to account for the universe's reference frame, if only implicitly, because an expanding area is not a meaningful concept without a reference frame relative to which the area expands. This is just a fact of intuitive logic, a fact which remains salient whether the reference frame in question is explicitly conceivable to our imaginations or not. So, for nearly a century, the fact that a reference frame for the universe is inconceivable was held in tension with the fact that it is still logically necessary. The dark energy problem represents the rising of this tension out of our subconscious and into the forefront of our awareness. It represents a lurking philosophical problem suddenly exposed as an acutely scientific one. Our failure to understand the basic logic of a universe that expands developed into our failure to explain the actual expansion history of the universe. The dark energy problem does not represent a failure in the equations of general relativity or a failure to detect an enormous amount of missing energy in the cosmos. Instead, it represents a more basic failure in our theoretical picture of reality, a failure to explicitly account for the reference frame relative to which the universe expands. The development of our theories of space, from Newton to Einstein, can be summarized as a three-step process, wherein scientists confronted an inconceivable, pre-theorized space as the positional quality of material objects, which was then transmuted into an absolute space that acts on material objects but is not acted upon by them, which was finally transmuted into a reciprocal space that both acts on material objects and is acted upon by them. As soon as this process was completed, it restarted on a higher level of analysis. Einstein's general theory of relativity, which concluded the first cycle in our development of theory, created the problems that initiated the second. For the last century, development has stalled between an inconceivable pre-theorized reference frame for the expanding universe and an absolute reference frame that acts on the expanding universe as the foundation of our conceptual system, but is not acted upon by the universe's expansion. To complete this second cycle in our development of theory, the universe's reference frame must be explicitly accounted for. It must be concretized as a fundamental aspect of reality in its own right, as space was once before. Subsequently, the two fundamental aspects of reality, the whole external universe and its reference frame, must be theorized in a reciprocal relationship with each other. To follow through on this process, we should remember that a crisis has occurred at the most basic level of our analysis, that a solution must therefore require a shift in our perspective, and that this transition, being so fundamental, must initially seem ridiculous. But it is also completely obvious. What is essential is that besides the whole external universe, another thing, which is not perceptible, a reference frame for the universe itself, must be looked upon as real, to enable the expansion of the universe to be looked upon as something real. Once a scientist fully and clearly accepts this predicament, it is a short way to realize there is only one available solution. Besides the whole external universe, what aspect of reality can anyone name other than subjectivity itself?